Welcome back to this live lesson series on algebraic fractions. Today we will be looking at the final series of algebraic fractions, which will be simplifying with quadratics. What you should know before this are these 5 lessons here. So you should have already watched algebraic fractions 1, 2 and 3, because that's going to tie heavily into today, and also, probably more importantly, factorizing quadratics 1 and 2. You need to be able to factorize quadratics confidently to be able to simplify algebraic fractions that have quadratics in them. So if you haven't already, I highly recommend that you watch those videos before you watch this one and try this worksheet. Okay, so that takes us on to algebraic fractions 4, where we will be simplifying fractions with quadratics. Okay, and as stated before, you need to know 1, how to simplify basic algebraic fractions, and 2, how do we factorize quadratics. So we'll sort of take a bit of a step back and look at how do we just simplify basic multiplication algebraic fractions where everything's been multiplied together. And we'll look at example 1. So example 1, we can see that we've got x plus 3 lots of x plus 2 all over x plus 2. Well, in algebraic fractions 1, looking at the most basic simplifying methods, we saw that if you've got a times b divided by a times c, we can cancel the a's to just leave us b over c. Okay, because it's all been multiplied together, and I said very clearly this only works if everything's been multiplied together. If you've got a times b and a times c, we can cancel off the a's to leave us just b, c. So how do we take this into this example? Well, we know if you've got a bracket next to another bracket, that means times. So essentially what we've got is, let's call this a and this b, and underneath, that's exactly the same as b. So those b's can just cancel, which means we can actually cancel the whole bracket because it's been multiplied together. So we can just say, look, that is going to cancel with that. So all I'm going to be left with is x plus 3. And do I need the brackets? No. So we can get rid of the brackets, because it's not being multiplied by anything anymore apart from 1. If I cancel this, I'm technically leaving it with 1. Okay, I'm getting rid of it and I'm leaving plus 2, and there's arguments that there could not be a bracket there. They might give it to you like that. I would just put a bracket in though, because it's going to help with what we're about to do. Well, what is on the denominator? A plus 2 squared. First of all, what does that mean? Well, we know hopefully that means we've got a plus 2 on top, and a plus 2 squared would be a plus 2 times by itself a plus 2. Well, what can we do here? We can cancel. Everything's being multiplied together, like the bottom's been multiplied together. We've got 2 terms in one bracket multiplied by 2 terms in another bracket, and we have the exact same 2 terms on top. So we can cancel one lot of that. So we could say this a plus 2 on top can cancel with one of these a plus 2's on bottom. And how do I write this? Well, as I just mentioned, when you cancel it, you're not leaving it as 0, you're leaving it as 1. So I need to put a 1 there. I'm leaving that with a 1 over, well, what's left on bottom? Just the a plus 2 on its own. So I don't need a bracket around it. I can just put a plus 2. Now, if you were to put a bracket around it, it's still correct. There's just no need for the bracket. So don't worry if you put a bracket and you think, oh, was that correct? It's still correct. There's just no need for it in this instance. We only need brackets here because we're multiplying them. Here we do not need a bracket. So the answer to that would be 1 over a plus 2. The next example, simplify. Well, what have we got? We've got x lots of y minus 3 all squared divided by another y minus 3 times by x. And again, this cancellation only works. You can only start crossing things off if you have everything being multiplied together. So I'm going to show you an example in a second where you can't just cross things off. And it's a really common mistake that students make. Everything's been multiplied here. The first thing I'll do is just say, well, what do we know this means? We know that means times by itself. So we can say x, y minus 3, lots of y minus 3, all over, well, we've got a y minus 3 here times by an x. Now, because everything is being multiplied together, we can do the cancelling method. Well, I can see I've got an x there and an x there, so they can be cancelled. Maybe I should use a nicer colour that you can see more clearly. This x cancels with this x. One of these y minus 3's can cancel with this y minus 3. So what am I actually left with? I'm simply left with, well, this has gone to 1, this has gone to 1. If I times all that by 1, I would just have y minus 3 over, well, that's all gone on the bottom. It's over 1, but is there any point me writing something over 1? No. So my final answer is this. If you write over 1, still correct, just there's no need. Okay, so let me just show you a method where you can't, or an example where you can't just do this cancelling. If I've got x squared plus 3x plus 2 over x squared plus 4x plus 2, you cannot do this. This is wrong. You cannot do this. This is completely wrong. You can't just be like, oh, there's an x squared. I'm going to cancel that x squared with that x squared. Oh, I can see an x there and an x there. I'm just going to knock those off. Oh, I can see a 2 and a 2. I'm just going to get rid of those and say that my answer is, what would I be left with there? 3 over 4, because I've cancelled everything. This is completely wrong, okay? You cannot do that, because the way in which cancelling works, you can only do a times b divided by b times c. You can only cancel things when they're being multiplied together. That's key. These on this x squared plus 3x, they're not being multiplied together, so you can't just cancel them off. They're individual terms. So this does not work. You can't just go around finding things that are the same and crossing them off. It only works when they are being multiplied together. So what have I written down here? Remember, I said these remember me boxes, really useful to put on a revision card. Okay, so a revision card for algebraic fractions and simplifying with quadratics would be this. If you see an expression or a quadratic, factorize it, then cancel. So we've just seen that we can cancel, we can have things in brackets, and as long as it's all been multiplied, we can cancel. So all I've written here is just a few different examples of what it could look like. You could end up with 4 brackets, 2 on top and 2 on bottom, where 2 cancel, tied together. So let's take this remember me tip into the next few examples. Okay, so example 4, it says simplify x squared plus 5x plus 4 over x squared plus 4x plus 3. So I definitely cannot do what I just said, which was start crossing off these x's and these x squareds and anything that looks the same. You can't do that. You should be thinking, if I see a algebraic expression or a quadratic, I need to factorize it. Which is why I said you need to be able to factorize. So if you cannot factorize or you find it difficult, go and watch my other 2 lessons on factorizing quadratics. But assuming you can and you can follow the methods that I'm about to do, we're going to look at how do we do this. Well, the first thing we're going to do, as soon as you see this, you should be thinking, right, I need to factorize this. And we know, hopefully, that 2 quadratics would go into 2 brackets. So I'm just going to set myself up. I know straight away that I'm going to have this quadratic go into 2 brackets when I factorize, and I'm going to have this quadratic go into 2 brackets when I factorize. And eventually, hopefully, if I'm correct, something should cancel off. I should get some bracket that's the same that I can just cancel down. So the first thing we should do, let's focus on the top one. If we factorize x squared plus 5x plus 4, remember, what do we need? We need 2 numbers that multiply to make c, because this is ax squared plus bx plus c from our quadratic series. We need 2 numbers that multiply to make c and add to make b, which is 5. So the method that I showed you was, you write down your factors of c, which is plus 4. What makes 4? 1 and 4, 2 and 2. You could have minus 1 and minus 4 because those 2 negatives multiply to make a positive. But because this is a plus 5, I probably only need the positive values. So do any of those make 5? Well, yeah, that's good. 4 and 1. So in my top bracket, it's going to factorize to x plus 4, or x plus 1 and x plus 4. It doesn't matter which way you write it, and we discussed this. So there you go. First bracket's been factorized. So hopefully in this bottom bracket, I'm going to get one of these brackets that are the same. So I can just cancel it down. So let's see. Again, we're going to need two numbers that multiply to make C, which in this case is 3, and add together to make B, which in this case is 4. So if I write my factors of 3 down, I'll do it in a different colour. If I write my factors of 3 down, what would I get? What makes 3? Well, 3 is a prime number, 3 and 1. Do any of those add to make 4? We could have -1 and -3, because they also times to make positive 3. Oh look, definitely. Which ones make B? 1 and 3. So I've got x plus 1 and x plus 3. Remember, we need these x's because how do you make an x squared? X times x. And factorising is the opposite of expanding. So if I expanded this out, I would get this. Okay. Everything I said came true. I've now got two brackets that are exactly the same. What can I do with those? Well, just like we were doing in example 1, 2, and 3, we can just cancel them off. So we can say, like, see you later to that one, see you later to that one, they're getting cancelled. What is my final answer? Well, I'm left with x plus 4 on top. Don't need the brackets anymore, because it's not being multiplied by anything. And x plus 3 on the bottom. And we're done. You cannot cancel that x and that x. That does not work, because it's not being multiplied by anything. It's been added to something. So our final answer is x plus 4 over x plus 3. So as you can see, this, remember me, exactly what I written down here happened. Okay, what was written here happened. I factorised and I ended up with actually two brackets on top, two brackets on bottom, and two of them were the same and they cancelled. So, you know, that's really good news for us. So our final answer is x plus 3 on the bottom and x plus 4 on the top. Going on to example 5. Now, this is where knowing about quadratics and factorising is really useful. The top one, what do we know about the top one? Well, they say proper quadratic. We've got a full quadratic, ax squared plus 2x minus 8. Okay. I know that that's going to go into two brackets, so I'm just going to bang in two brackets. So I'm just gonna pause on that one. I'm going to think about that in a minute, but I definitely know if I factorise the top, it's going to go into two brackets. So what do we need? We need two numbers that multiply to make -8 and add together to make +2. So same method as I taught you in the quadratic series. We're going to list the factors of -8. How do you make a minus? You need a mixture, one positive and one negative. So we could have -1 and +8, or we could have 1 and -8. We could have -2 and +4, or 2 and -4. Do any of these make +2? Well, -1 plus 8 is 7, so not that one. 1 take away 8 is -7, so not that one. -2 add 4. What's -2 add 4? That is +2. So we found it. It's that one. It's -2 add 4. If you look at the other one, what's 2 take away 4? That would be -2. So it can't be that one because we need +2. So what's going to go in my bracket up top? It's going to be x -2 and x +4. So now we need to deal with this bottom one. Well, this bottom one's a bit weird because it doesn't have a c. It's got an ax squared and it's got a bx squared. Bx, sorry, but it doesn't have a c. It doesn't have the plus c. So this will not go to two brackets. So this is basic factorising. Okay, we need to basic factorise this. What is common in both x squared and 2x? Well, x is common in both, so I can bring an x out. So this is just going to go to one bracket. What would be left in the bracket? Well, if I take x out, what do I have to times x by to get x squared? That would be x. What would I have to times x by to get -2x? Well, -2. So this bottom bit is a quadratic, but it's actually a quadratic that will only factorise to one bracket. Has what we foreshadowed happened? Yes, we have got two brackets that are the same. So what do we do with those? We can cancel them. So I'm just going to cancel that x -2 and this x -2. So what am I left with? Well, on top I'd be left with just the x plus 4. And on bottom I'd be left with just x. So that is my final answer. And again, I cannot just start cancelling off x's. That's it, we're done. They're not being multiplied, so you can't cancel them down anymore. We factorised, we found two brackets that were the same on the numerator and the denominator, and we cancelled them down. So we're done. So again, you must be able to factorise to be able to do this part of algebraic fractions. Example 6. So example 6 is an interesting one because we're going to talk about a special type of quadratic. But before we do that, which one do we know we can factorise easily? Well, hopefully you're thinking, top one looks a bit weird because it's got an x squared and a c, but it doesn't have a bx. But the bottom one is perfect. It's got an x squared, it's got a bx, and it's got a c. So you should be thinking straight away, I can factorise that into two brackets. Okay, straight into two brackets. Well, what do those two brackets go to? Well, we need to do our factorising method. We're going to see what multiplies to make c and adds to make b. So what numbers multiply to make 24? How do we do that? We're going to list the factors of 24. We've got 1 and 24, 2 and 12. Okay. What else? 3 and what else makes 24? 6 and 3. 6 and 3. What else do we have? 24. 8 and. Sorry, not 6 and 3. 6 and 4. God, I can't do my times tables. 6 and 4 and 8 and 3. Why am I not gonna? I'm not gonna bother listing the. If you're good at quadratic factorising, you don't have to list all of your factors all of the time. If you understand, my b is positive and my c is positive. Therefore, I'm only gonna need positive options. If this was negative, I would need some negative options. Okay, which one of those adds to make 10? Oh, 6 and 4. Brilliant. 6 and 4 add to make 10. 4. And add to make 10. Let's focus on the top. Top's a bit of a funny one because we saw a minute ago that when you've got two terms with an ax and a bx, it only goes to one bracket. Okay, that's what we saw a second ago. This one, however, this top one is going to go to two brackets, even though it's only got an a and a c, an ax squared and a c. Why is it going to go to two brackets? Well, it's something very special that we call, and we'll talk about it now. This here is what we call the, I'm doing a different colour, the difference of two squares. Okay, the difference of two squares. And what that says is, and why is it called the difference of two squares? Well, we've got x squared, which hopefully you'll agree is definitely a square because you're squaring it. And 36, is 36 a square number? Yeah. 36 is 6 times 6. So 6 squared makes 36. So we say that 36 is a square number. And what does difference mean? Difference means you take them away. Yeah. If you find the difference of two things, you're taking them away. So that is what we call the difference of two squares. And you should be trying to spot that all the time. If you've got a square, which x squared is definitely a square, minus another square, which could be just a squared, or even a number, which is a square number, in this case 36, there's something very special that happens with this factorization. What we say is this: a squared minus b squared. So in this case, a is x and b is 36, because that's a square number. That will factorize into this: a plus b and a minus b. Okay, a plus b and a minus b. How do we relate this to this quadratic here? Well, x is a, so it's going to be x and x in the bracket. So we know that, don't we? We know that to make x squared, you need x and x. What I should put here actually is the square root. It's plus the square root of b and minus the square root of b. Apologies. That's minus the square root of b and plus the square root of b. Okay. That is plus the square root of b and minus the square root of b in that bracket. So we need to put plus the square root of b in here and minus the square root of b. Well, what is our b? Our b here is 36. Okay. What's the square root of 36? 6. So I need a plus 6 and a minus 6. Now, this always throws students when they see it in an algebraic form where it can be applied to anything. It always makes them a bit confused. But if we just take our example above, what happens if we expand out this? X times x is x squared. X times minus 6 is minus 6x. So we've got x squared minus 6x. 6 times x is plus 6x. And 6 times minus 6 is minus 36. Well, look at that. X squared minus 6x plus 6x minus 36. What happens to those terms in the middle? They cancel. Minus 6x plus 6x goes. So what are we left with? X squared minus 36. So if I had x squared minus 100, that would factorize to, is it the difference of two squares? Yes. You've got x squared minus the difference of 100, which is a square number. That would go to x plus the square root of 100, which is 10, and x minus the square root of 100, which is 10. So you can, and you only know up to maybe 15 squared, so you only have to recognize 15 square numbers. You know, 2 times 2 is 4, so 4, 9, 16, 25. If you see x squared minus 25, you would be like, oh, x plus 5, x minus 5. So that's something that we might look at in more detail in the next quadratics lesson. But that is the difference of two squares. What happened? If we go back on, we went on a bit of a tangent there. If we go back onto the actual simplification of this algebraic fraction, we can see we had an x would be exactly the same, so we can just cross them off and cancel. See you later, that one. See you later, that one. What are we left with? We're left with x minus 6 over x plus 4. And that is done. That is our final answer. Okay, so the bottom bit of that, easy, yeah? Basic factorizing a quadratic. The top bit, this is very important. So we might even put that in a box. That is something that you could put on a revision card. And maybe even put this example in with it so you can see it working with real numbers. But that's very important. The difference of two squares, very, very important. Okay. So that brings us on to the final two examples where we're now going to look at the harder factorizing quadratics, which we saw in the second lesson on that series. I can see that we need to simplify two quadratics, and they're full quadratics. Yeah, they've got an ax squared, a bx, and a c. So what we can do is set ourselves up. What do we know? Well, hopefully, you know that both of these quadratics will factorize into two brackets. So I'm just going to bang in two brackets ready, and that tells me that I need to factorize these two brackets to then see if anything cancels. Hopefully it will. So let's deal with the top one first, because we refer to that as the easy version, because x squared is just 1. There's no coefficient of x squared. How do we do that? Same as usual, we find two factors that multiply to make minus 8 and add to make minus 2. What are the factors of minus 8? Minus 8 come from two mixtures, so a mixture, of positive and a negative. What makes 8? Well, minus 1 and 8, or 1 and minus 8. Minus 2 and 4, or 2 and minus 4. Okay, which one of those make minus 2? Well, definitely not the first two. Minus 2 add 4 would be plus 2, so that's no good. 2 take away 4. Well, if you're at 2 and you take away 4, you get to minus 2. So that's good. It's that one. So it is the 2 minus the 4. So we've got x minus or plus 2 and x minus 4. It doesn't matter which way you put it. That's that one sorted. The bottom one, well, why is this one harder? Why is 3x squared plus 7x plus 2 harder? It's actually, if you know the method, just as easy, just takes longer. But why do we consider that as harder? Well, If you saw that lesson on Factorizing Quadratics 2, you would have seen that the a, if a is greater than 1, then it is referred to as a harder quadratic and has a different method to solve and factorize. So because our a is bigger than 1, is 3, we need to do this method. We need to take a and c together and multiply them. So we're going to multiply a and c. Well, 3 times 2 is 6. Then we're going to list the factors of 6. 1 and 6. 2 and 3. I'm not going to put my negative options because I can see that b is 7. B is positive, which means a, c and b are positive. I'm just going to need positive options. We're looking for which one of these new factors that came from timesing a and c together make 7. Which one of these make 7? Well, 1 and 6. If I add 1 and 6, that makes 7. So what we do now is we rewrite out our quadratic. So we write 3x squared. And we're going to replace this plus 7x with these new factors. Okay? So we're going to say plus 1x plus 6x and then plus 2 on the end. So if I color coordinate this, this is the 7x. Okay? This has come from the 7x. If I simplify that, what do I get? 7x. You've got to think of this as pulling this quadratic apart. And the a and the c haven't changed. They've just stuck around. Yeah, they've stayed. And I spoke about making an informed decision here. You get to decide if you want to put 1x first and 6x first, or 6x first. Because what we're going to do now, hopefully you remember, is split it down the middle. What comes out of that? Well, the biggest number would be just 1, so there's no point. But that's got an x squared and that's got an x. So I can take 1x out. What would that leave me with? What do I times 3x by, or x by to get 3x squared? It would be 3x. Yeah, x times 3x would give me 3x squared. Plus, what do I times x by to get 1x? Well, that would be 1. The trick here was these brackets will always be the same. So we can just fill in. We know that these need to be the same. So I can just fill in 3x plus 1 in here. Work backwards. What would have to be here to expand to get this above? What do you times 3x by to get 6x? 2. Does it work? What's 2 times 1? 2. So we're all good. It works. We're done now. We factorise this. Remember, once you get to this point, therefore, our two brackets are going to be the combined repeated bracket, so 3x plus 1 is one of the brackets. What goes in the other bracket? Well, the bit that goes in the other bracket is the leftovers. Yeah, the things that we factored out. Okay, so what did we factor out? We factored out, I'm running out of colours there. Let's get a different one. Maybe a pink. This X and this, well, that's a little bit close, isn't it? It's a little bit close in the same colour. So what colour haven't we used? Green? No, we haven't used green. So X and 2. That goes in X plus 2. That's where that bracket comes from. So we have now factorised this harder quadratic. Yeah, and if that method, if you haven't seen that method before and that's the first time seeing it, go back and watch Factorizing Quadratics 2, because I break it down in a lot of detail there. So in here, I can now put in my factorised answer, which is 3x plus 1 and x plus 2. Okay. And I'll just colour coordinate that so you can see where it's come from. Well, what can we see here? We can see we've got a repeated bracket on the bottom and the top, and it's all been multiplied together. So we can cancel this off. Okay, we can cancel off the x plus 2 and the x plus 2. And what do we get? We get left with x minus 4 over 3x plus 1. And we're done. And that is the final answer for that question. So basic factorising gives us the two brackets on top. Using the method for when a is greater than 1 would give us the brackets for the bottom. and then it's a case of cancelling them down. Okay. So that takes us on to the final example, which is example 8, which has got a harder factorising quadratic on top and a very sneaky difference of 2 squares on the bottom. So let's deal with the top part first. If we need to factorise the top, we know that it's going to go into 2 brackets, definitely. And we'll just pause on the bottom bit and we'll discuss that together. If I'm going to do the top, we need to copy it out and we need to realise that a is greater than 1. Okay, so if I factorise this, a is greater than 1. So my a is, in this case, again 3. So I'm going to multiply 3 and 4 together. So if I multiply 3 and 4 together, what am I going to get? We will get 12. We need to list the factors of 12 that add together to make minus 13. So in the last example I said because it was all positive I can just ignore the negatives. Well, I've got a negative here, so I need to show my negative options. I'm never going to be able to make a negative number by adding 2 positives together. It's never going to happen. So I'm only going to list my mixture, my 2 negative versions, because how do you make plus 12? Well, 2 negatives make a positive. So I'm going to write minus 12 and minus 1. That times together to make 12, but add together to make, oh look, minus 13. I found it on the first one. We could have put minus 3 and minus 4 and gone down. Where do we go from there? We rewrite out the quadratic, 3a squared. Now I'm going to replace this minus 13 with minus 12 and minus 1. Okay, minus 12a, minus 1a, and then the plus 4 on the end. So remember, a and c haven't changed. They've stayed the same. The only thing that I've done is rewritten minus 13 as those 2 factors that actually do, when you simplify them, do make minus 13. Then we're going to split it down the middle. So if we split down the middle, we're going to factorise each side. If we focus on the left, what can I take out of 3a squared and minus 12a? What's the biggest number I can take out? Well, 3 goes into both. This has got a squared and this has got a. So I could take out a, 1a. What would leave me in the brackets? 3 times what gives me 3a squared? Well, a. Minus 3 times what gives me minus 12a? Well, minus 4. Okay. And we know that these brackets, the little trick here is to know that if we've done this method correct, those brackets need to be the same. So if you know they need to be the same, we can just fill them in. Once you factorise this side, just copy that bracket in there and work backwards. What would need to go here? When I multiply a, I need minus 1a. And when I multiply minus 4, I need plus 4. Well, we know 2 negatives make a positive, and minus 1 times by a would give me minus 1a, and minus 1 times by minus 4 would give me plus 4. So that works. So we found it. Therefore, our 2 brackets are going to be a minus 4 definitely, because it's the repeated bracket, and then the leftovers 3a minus 1. So that's what goes in my leftover bracket. 3a minus 1. So this 3a and this minus 1 make up the other bracket. So that's good. We can go and fill those in. We've got 3a minus 1, and as you can see, I've written it the other way now. And a minus 4. That and that is the same thing. That is exactly the same thing, they're just written the other way around. Because we know if we multiply, it doesn't matter which way we put it. So now it's our job to look at the bottom and see what the hell is going on with this. Well, what have we got? We've got minus 1 taken away from 9a squared. Well, is it the difference of 2 squareds? Is it the difference of 2 squared? Right, difference of 2 squares. Is it that? Yes, it is. Why is it? Well, is 9 a square number? Yes. Is a squared? Obviously, yes. Is it the difference? Minus, yes. Is 1 a square number? Yes, it is. And that's what usually gets people. What is 1 times 1? 1. So 1 is a squared number. So we've got all of these things squared and it's the difference of them. So we're going to need 2 brackets. We're definitely going to need an A and an A, but how are we going to make 9A squared? What do you times together to make 9? By itself, 3 and 3. So look, 3A times 3A would give me 9A squared. 3 times 3 is 9, A times A is 9A squared. And then I need the square root of this, remember? What's the square root of 1? 1. So I need plus 1 and minus 1. If I expand this out, I'm going to get 3A squared minus 3A plus 3A. 1 times minus 1 is minus 1. What happens to these A's here? They cancel. So what am I actually left with? 3A squared minus 1, which is, sorry, 9A squared. God, I've lost it. I've lost my head today. 9A squared. Because obviously 3 times 3 is 9. So on the bottom, we can put in our difference of 2 squares. It's 3A plus 1 and 3A minus 1. Maybe I'll just make this smaller so it's not in our way. Maybe put a box around it as well. So difference of 2 squares definitely will be something that I'll be looking at in more detail. What have we achieved? We've factorised the top and the 3A minus 1, and what else is the same? 3A minus 1. They cancel. So we just bang those off. And what are we left with? We're left with A minus 4 over 3A plus 1. And that would be that question done. So this would be considered like a grade 7 question because you are being expected to do a lot of different things. But as you can see, you must be able to factorise and you must understand the principles behind when you can and cannot cancel. And if you know those 2 things, these are quite straightforward. So if you got a little bit lost with any of this factorising here, go and watch the other factorising lessons that I've done because it will make it a lot more clear because I actually spend time going in detail on it. Here, I'm assuming you know it, so I've just gone through it. But if you don't know it, go back and check and then maybe rewatch this video. But that is a selection of all of the different types of factorising and quadratics that you could have where they ask you to simplify. The takeaways, biggest takeaway here, if you see algebra and quadratics in a fraction and they've asked you to simplify it, factorise and then hopefully stuff is going to cancel.